Hello and good afternoon to all of you. I hope all of you are doing well. So in today's class, we're going to discuss about function-oriented design. Now, function-oriented design strategy basically tries to decompose the overall system into a collection of interacting functions with the centralized state information. So this we have already learned in the previous class as well. So function-oriented approach basically decomposes the system as a collection of interacting functions where the overall state information is centralized. We have learned about various problems associated with the centralized data store. We'll come to that again. Now, function can also maintain their own local information, but it will be available only during the execution of the function. So this is very much true. Each and every function can maintain their own local data, but it will be available only during the execution of that particular function. Now, in case of function-oriented approach, so functions can maintain their own local state information, but the state information will be available only during the execution of the program. Now, in case of function-oriented approach, the way how the algorithm is implemented is concealed. Concealed basically means it is hidden, right? But the centralized data store is not hidden. That makes the centralized data store vulnerable. We've been repeating this particular point time and time again. Now, change in one of the function and the way how it accesses the central data store may bring about an unanticipated change in the way other objects or other functions behave, right? Okay, because as the as the state information is centralized, so any function can have access to it. So whenever a function brings about anticipated or unanticipated change to the central data store, so what happens is that any other function that uses data then onwards may generate some erroneous result. Now, a function-oriented approach design is therefore suitable only for situation where the information content is very limited or the data sharing, explicit data sharing constraints are imposed. Now, let us try to understand few of the concepts related to function-oriented design. The first one is called as data flow diagram. Now, data flow diagram is a diagram that shows data flow that takes place between different functions that are present in a given system. So data flow diagram is a graphical representation of flow of data through information system. So how the way how the data flows between the various functions in the information system is represented with the help of a data flow diagram. So data flow diagram is also used visualizing data processing. Okay, a data flow diagram provides no information about the timing of the process or about whether the process will operate in sequence or in parallel. So the invocation relationship is not represented in case of or in case of data flow diagram. It basically shows functions and the flow of data between them. No invocation relationship established. So that differentiates data flow diagram from flow chart, where flow chart chronologically orders the task that is to be performed, but in case of data flow diagram, what we do not have is we don't have invocation relationship, so we don't have that timing information being provided in case of data flow diagram, right? So it is therefore quite different than that flow chart, which shows the flow of control through the algorithm, allowing a reader to determine what operations will be performed in what order and under what circumstances. So this is very much important. So a data flow diagram is different than that of a flow chart because in case of data flow diagram, the invocation relationship or the sequence of execution is not explicitly represented or not represented. So here it basically shows data flow between the various processes. Now, there are different versions of data flow diagram. The first one is called as context label diagram, and the second, the latter ones are called as subsequent labels in data flow diagram. So, the context diagram is a diagram that represents the context of the system, right? Again, it is a diagram that represents the context of the system, and it is the only diagram that shows a system and the interaction with and its interaction with external entities. So a context diagram is a diagram that represents a single a system as a single process that interacts with the external entity, and it's always labeled with a noun and it's tagged with an identifier 0. So context diagram is a diagram where the uh, a process is tagged with the name of the system and it's labeled with tag 0, and it is the only diagram that shows interaction between the external entities and the system. So here what we have is we have a single process representing the entire system. So this is very much important. So whenever we will be trying to understand, whenever we will be trying to or when we'll take at point in time, what we'll do is we'll take an example and we'll try to understand context diagram, right? But for now, just remember, context diagram is the only diagram that shows interaction between a system and the external entity. It is labeled with a noun and it's tagged with an identifier 0. Now, the subsequent label of, or it's also called as label 0 data flow diagram, right? So context diagram is also called as label 0 data flow diagram. So for now, just remember that context diagram is a diagram that represents the context of the system. It is labeled with 0. It is tagged with an identifier 0 and labeled with a noun, and it is the only diagram that shows interaction between the system and the user. Okay. And the system and the external entity of the user. Now the context diagram is then exploded or it's factored in order to produce the first label data flow diagram, right? Again, label 1 data flow diagram. So label 1 data flow diagram highlights all high level functions that are pertaining to the system, and then these diagrams are named with a noun verb combination, okay, and with an identifier that is x dot y, where x is the ID of the parent and y is its own unique ID. So it is, so for an example, 0.1 is the first child of the context process, okay, right? So that is the way how it's labeled. So context diagram is exploded or factored in order to produce label 1 data flow diagram, where later label 1 data flow diagram models all the high level functionalities, right? Okay. So label 1 data flow diagram shows the system, shows how the system is divided into sub processes, each of which deals with one or more data flow. That's very true, right? So it is. It also identifies internal data store that must be present in order for the system to do its job, and shows the flow of data between the various parts of the system. So this is also very true. Whenever you are creating a data flow diagram should also represent various data store with which it interacts in order to perform operation. Okay, and the flow of the data in between them. Now, label 1 diagram identifies the major business processes at high level, and any one of these processes can be further analyzed, giving rise to corresponding label 2 business process diagram. So this is very much important, right? Okay, you see, so label 1 diagram identifies all the high level functions or business processes that are there at high level, and any of these functions can be further analyzed in order to elaborate and create the second label data flow diagram, right? Now, you can express the data flow diagram at different labels. So you can have label 1, labels, you can have label 0, label 1, label 2, label 3, but so on and so forth. But you need to ensure that the description of the system in terms of data flow diagram does not exhibit the internal working. So normally what we tend to do is we tend to restrict it to label 3 or label 4 data flow diagram, right? Okay? So in this portion, what we have learned is we have learned that we have different versions of data flow diagram. We have context diagram. So context diagram is a diagram that is able to represent the context of the system. It is tagged with the identifier 0 and named with a noun, and it is the only diagram that shows interaction between the external entity and the system. Then the context diagram is exploded or factored in order to produce label 1 data flow diagram, where later label 1 data flow diagram identifies all the high level functionalities. It also represents the data store with which it interacts in order to perform business. So label 1 data flow diagram represents all the high level functionalities with the associated data flow. Now, we have further stated that any of the high level functions in the label 1 data flow diagram can be selected and exploded into second label data flow diagram. We can continue to till the third or the fourth label until unless the internal complexity is not reflected, right? Okay, so here, this is what is data flow diagram all about, right? So in today's class, what we learned about is we learned about what is function-oriented design, and we have what we learned about what is data flow diagram, right? Again, and we have learned about different types of data flow diagram. Now let us try to move on some of the important data flow notations. Okay, so there are different notations being proposed by different authors. So we have process notation proposed by Jordan and Codd, right? So Jordan and Codd has proposed process to look like this, right? Again, it's represented with the help of an oven, right? Again, where we have the process identifier and the process name. Likewise, we have Jane and Sarson notation where it's represented with the help of a rounded rectangle, right, which is an identifier and the name of the process. So we can use either of the notation. You can use Jordan and Codd notation or Jane and Sarson notation. Then we have data store notation. So Jordan and Codd represents data store with the help of a parallel line, whereas Jane and Sarson represents data store with the help of this particular notation where you have the ID associated with the data store as well. So data flow is represented with the help of an arc, right? Again, data flow is represented with the help of an arc with an associated data here. So, for example, X, right? Again, because simply an arc represents control flow, so data flow is represented with the help of an arc with an associated data. Now, external entity is represented with the help of a rectangle. So it's an external entity. So either of the notation can be used in order to represent external entity. Now there are certain data flow rules that are to be adhered to, right? Okay. Now just see, we have certain data flow rules that are to be adhered to. So external entities. So here it is normal for all the information system represented with this within a system to have been obtained from or to be passed on to an external source or recipient. So it's very true, right? Again, so all the information system can interact with an external entity in order to communicate information to or from, right? So an external entity may provide information to a business process, or an external entity may take information from a business process. So whenever we are trying to represent, so this is a mechanism of representing external entity where we use lowercase letters for the external entities, right? Again, now processes. So whenever naming a process, what we need to do is we need to ensure that we avoid confusing names. So process has to be named with the help of a strong noun verb combination. So that is the indication of a name for a process. So it has to be named with the help of a noun verb combination. So an example, generate report, right? Again, or so an example, update report, or so for an example, generate receipt, right? So and so forth. So process has to be named in that particular manner. So it has to be a very strong noun verb combination. So the most important thing to remember is that the description must be meaningful, right? So just see, whenever you name a process, the name has to be assigned in such a manner that the name has resemblance with the behavior of the process, right? Now data flow. Now, data flow can be between process and a process. So we'll learn about the data flow rules, but there are different ways in which what we can do is we can use data represent data flow. So you can have a unidirectional arrow or a bidirectional arrow, right? Okay, a unidirectional arrow basically represents to, and bidirectional arrow basically represents to and from, right? Okay, now data store, with each and every identified data store we can have a character associated, D, M, and T. D means it's a permanent computer file, M means it's a manual file, and T basically means it's a transitional file or transient file. Transient file basically means a file that's temporarily created or deleted after processing. Now, you see, these are the data flow rules that we have. So, two external entities are allowed to interact with each other, and external entities are allowed to interact with the process, and external entities not allowed to directly interact with the data store. So, that's very true. It has to be done through the process. Now, process and the external entity can interact with the process. So, this is also implied here. So, process can interact with an external entity. So, process can interact with the process, and process can interact with the data store, right? And a data store can interact with another data store, right? Okay, so this is very true. So here it basically implies it's not capable of interacting with the external entity, but it's capable of interacting with process, but it's capable of also interacting with another data store in case of relational database management system. So this is data flow rule that we have. So in today's class, what we have learned about is we have learned about what is function-oriented design, right? We have learned about how function-oriented design tries to perceive a system as, right? Again, we have learned about what happens when the data store is centralized. We have learned that the function can maintain their own local data as well, but it's just true only during the execution. We learned that function-oriented design conceals or hides the way how the function is implemented, but does not hide the data. So this brings about a kind of problem in case of function-oriented design, where a centralized data store, if accessed by the function intentionally or unintentionally, may lead to other functions generating erroneous result. Then we learned about data flow diagram. We learned what is a data flow diagram. It's basically a representation that shows the flow of data. Then we learned about the importance of the data flow diagram. We learned that the data flow diagram is not capable of representing parallel execution, right? And we've learned about the difference between data flow diagram and a flow chart here, right? Again. Then we learned about what is a context diagram, right? How it should be labeled, how it should be named. Then we learned about exploding context diagram into subsequent labels of data flow diagram, and how it has to be named and how it has to be labeled, right? Again, then we've learned about the way how the interactions are to be placed in the subsequent labels of data flow diagram. We learned about to what extent of detailness we can move ahead in the decomposition, so we can move on to third or the fourth label, beyond which it may so happen that your representation may reflect internal complexity. Then we've learned about different notations. We've learned about process notation and process notation, data store notation, proposed by Jane and Sarson and Jordan and Codd. Then moved on to data flow notation. Then we try to understand the notation for external entity. Then we try to go through some of the data flow rules associated with external entities, right? Again, processes and data flow. And then we try to associate some of the attributes with the types of files. And then we learned about different data flow rules that are there between external entity, process, and data store. So thank you very much. Have a very good day.